Hello everyone and welcome back to the channel. Today we have a repair of a Parkside power screwdriver. I have been using this for many years and it has served me very well. Model number is PASS 3.6A1 and is it the same? Yeah, at the back. And as you can see, it's a single cell 3.6 volts screwdriver. The original battery failed very early, about 3 years I think after the purchase, and I did replace it with Panasonic one. Not the best choice because they don't have very high discharge rate, but it has been working very well. Now I went ahead and replaced the battery without checking anything, and actually the battery was not the problem. I measured the old one and it was down to 0 volts, which was a bit strange. I've never seen those fail in that way, the Panasonic, the green ones, the 3.4 milliamp hour. Am I missing something here? Is there a screw there? Yeah, that's what I was missing. And here we are. Very simple construction, just an on-off switch and the reverse forward for the motor, screw over screw. It would be nice if it had the variable speed mechanism. Now I'm going to remove the battery so we can check the PCB. Out of curiosity, let's take a measurement. So yes, our battery is charged, so that is not the problem. As you can see, I have soldered the wires. Soldering iron is hot, I think. Let's get this one and this one. Let's take a look at our PCB. This is the indicator for the charge LED. I have no idea if any controlling of the charge process is through here. There is only one. I think it should be a MOSFET. I cannot see any fuses or anything like that. So actually negative goes to the MOSFET and positive here. So this thing looks absolutely like there is no power to it. Let's go ahead and check the MOSFET. So looking more closely at the circuit, we can see that this MOSFET or transistor is operating the ground from the battery and connects it to everything. We can apply I have my power supply set at 4.1 volts. So measuring from 0 volts to the gate of the MOSFET, we get about 1.18 volts, which is just above the minimum to operate the gate. Nominal it says about 1.6 volts and minimum 1. Now we'll cut the power. And let's try to find out. We can see the trace going here. Does it go? No. It goes here. Yes. So it goes to pin 1 of this IC. And this is a battery protection IC. We can see pin 1 is indeed the fade gate control pin, and I think that this might be the suspect for not getting any power at all to the motor or the light. I will go ahead and replace this IC. The part number is going to be in the description. I have our part here. I'm gonna put just a bit of flux, sorry. So here's the hot air gun. I have it set at 350. It shouldn't take long to remove it. There we go. Let's get the new part there. So it has a line, the line should go there. I'm gonna just try to solder it back with the hot air. Should add a bit of flux. Most of the times I find it easier to remove the solder with a wick and resolder it with the soldering iron. Oops. Take a look with the loop. And everything looks soldered nice. So back with the power screwdriver. After so much effort and time trying to repair this, I saw that Lidl had a new one next week, and I thought I should give it a look again. I have my power supply set at 4.1. And I hooked it up to give it a test, and sure enough, the thing is working properly. Only thing I have replaced is this battery controlled charger IC and the capacitor on the back here. So obviously this must have been the problem. Link of the part number is in the description below. So I will assemble it back, solder a battery to it, and take it for a test again. See you in a bit. Battery is soldered, as you can see, and let's put the last cover and see if it works fine. So finally it is assembled, and so happy with it. I'm pretty sure it will work for many years more. Hit the like button if you found this video interesting, and please consider subscribing for more. Thank you for watching, and see you on the next one. Bye!